Hello, everyone. Thanks for joining in. Let's get started. What you are already experiencing in the field of data science. All right, all of us, in some form or shape, in the current day, have been experiencing data science in a lot of ways. Right. Take for example YouTube. Right. But the moment you watch a YouTube video, the moment you see relevant video content that is available right next to it, right next to the video that you already watched, and a lot of days you probably wouldn't even realize that a video like that actually existed if not for YouTube actually pushing YouTube actually recommending that to you. Similarly, Netflix or let's say any streaming platform, whenever you watch a video, similar content is always pushed for you to or recommended by that particular platform so that you get to watch the content that you really like. That is in a lot of ways what data science really is, right? Also, take the example of sports, right? Take the example of let's say English Premier League teams, or let's say take the example of the Indian Premier League cricket team auctions that typically happen. There's a lot of analytics that goes into how teams are decided, which player is decided at what position, and if the particular team needs to go for that particular player or not, while they're bidding their auction. What should be the maximum cap beyond which the teams actually shouldn't bid for a particular player. So all that, a lot of analytics actually goes in, a lot of intelligence goes into who should be playing a particular game and what position should a particular person be playing, and things like that. So if you think of it, there's a lot of analytics and intelligence that is baked into sports as well today. More importantly, we were recently working with a diamond mining company in Botswana, and that particular company apparently contributes to almost 30 to 40% of Botswana's GDP. And imagine we were working in that particular location, trying to build systems that could automatically identify if a particular machine is likely to fail in the diamond mining site. Imagine if a particular equipment goes down in the middle of the complete mining exercise. Imagine the kind of challenges uh, that the mining company goes through every hour. They keep losing money if the equipment actually doesn't work, right? So imagine um, when an equipment goes down, and in remote areas, especially mines are always in remote areas. Imagine how difficult it would be to send out, let's say, a service personnel after the event actually occurs. But if we could make use of some information, some historical data, and then predict if a machine is likely to go down, then even before the machine really goes down, you could send a service personnel out to actually rectify the issue, which would save a lot of time, b a lot of money, more importantly, right? That is called predictive maintenance, and that's a big application of the field of data science. You name a field and there are numerous applications of the field of data science. um, one of the most recent additions into this particular thing is, take for example, the game of Pac-Man. Right, Pac-Man is a game we've been playing since a very long time. And all of us as kids, when we used to play the game of Pac-Man, it's a very simple, silly game. But then the reason why it is so intriguing and interesting is because as the game progresses, it keeps getting faster, and there's these monsters that try to eat you away. But then that's the nature of the game. But imagine if you can build an intelligent system that could automatically play by itself or learn as it goes along, right? Or playing a game of chess against the computer. And imagine if you can build an algorithm, or if you can build an intelligent system that could automatically play chess against the computer, and it could beat the opponent, let's say, right? So these are some cool and very interesting applications of the field of data science. Self-driving cars, right? Or driverless cars, let's put it that way. What Tesla has done is just phenomenal, right? And actually bringing it into the consumer world, while all of this driverless and self-driving cars as a fad is awesome, but imagine bringing that actually into the consumer world. A driver sits in the car and then actually takes the hands off the steering wheel, and the car takes control of how to drive through the how to drive through the streets. Yeah, I mean, it's still a distant reality in India, because because of reasons that we all understand. Uh, but then uh, but then yes, driving in India is just crazy, right? So it gets really difficult. Forget about You really need extreme levels of intelligence to actually drive in India. Uh, but then, uh, but then, yes, we're probably not that far away to build driverless systems in India. But there's a lot of testing that's going on already. So the point is, what is data science? When we say what data science, if you look at one common element across all these aspects that we just spoke about, the commonality is intelligent systems, right? Building those intelligent systems. Now, the question is, how do you build these intelligent systems? When you say intelligent systems, what do we actually mean by it? The definition of an intelligent system is something as silly as if the machine itself has the ability to make a decision by itself. The machine itself has the capability, has learned so much over a period of time that it has the capability to start making decisions by itself. That is what is typically referred to as a that is what is typically referred to as an intelligent system, right? Is a washing machine an intelligent system? Well, as a matter of fact, it was 10 years ago or 20 years ago. What a washing machine was an intelligent system. Now it probably has become a dumb system because it just runs on a set of 10 modes, right? But 20 years ago, when 20 years ago, to define intelligence, it had to be some rules, right? We had to say that, okay, spin, you had to define how a washing machine was supposed to wash clothes, or let's say how a robot was supposed to, let's say, clean your house. But today there are systems that can automatically understand based on the type of the cloth, based on the amount of volume that you have. The washing machines are now smart enough to automatically adjust the spinning rate, the amount of water they use, and so on and so forth. Similarly you have home robots in your house that, based on where the dirt is in the house, they automatically clean that place for a slightly longer period, and they use different kinds of ways to clean that particular place, and so on and so forth. So intelligence is of different levels. Intelligence can be something as simple as a 15-year-old or a 10-year-old, or let's say a 5-year-old washing machine. Intelligence can also be something as complex as what Tesla is currently doing today, building completely autonomous cars, self-driverless cars, so to say. So intelligence can be at different levels. What we are trying to do is we're trying to move away from the traditional machine intelligence that was devised, let's say, 15 years ago, 10 years ago, trying to build these simple programmatic systems, to real intelligent systems where they actually have the liberty to make decisions, right? Take the example of Uber, the Uber app. When you make an Uber booking, even before you actually make the booking, you're given an estimate of what would be the price of that particular trip. Now, how does Uber make that decision? Right? There's so much that goes into actually identifying how much price should Uber actually charge you even before you take the trip. Think about it. Earlier, 15 years ago, 10 years ago, or at least 5 years ago, let's say, um, when we had to make a booking, when we took a cab, we had to go through the complete trip, and there was a meter that was ticking on continuously. While of course our mind was in reaching the destination, one eye was always concentrating the meter on that is sitting right in front of you, because you know that that's a ticking time bomb, and you know that the more you go around, the more you spend. So, but think of what Uber has done. Uber has actually changed the complete course. They said, you know what, look, don't worry about you don't worry about actually reaching the destination to know what price. We'll tell you what the price of your trip is going to be even before all of this actually happens. So what Uber has been able to do, they've been able to build an intelligent system that automatically predicts what the price of this particular trip is likely to be based on your start point, your end point, the weather, the number of people who are traveling, the kind of cab that you've booked, and the location that you're in, this if there is a high demand or not, and thousand other elements, right? And the traffic in that particular location, and thousand other factors go into actually identifying the price of that particular trip. If the system is not that intelligent, and if it predicts way too high, then as a user I would be super disappointed, because I know that I would be spending very, very less. I would not be making a booking because it would be too expensive. On the other hand, if the machine predicts very low, then Uber is going to run into losses, right? So imagine how precise that particular intelligence has to be, right? So what we're essentially saying here is, when I say data science is basically a field that is sort of responsible for building these intelligent systems. The more and more systems become intelligent, the more and more smartness you start baking into these systems. Uh, what that does is it gets rid of firstly a lot of unnecessary decision making that we personally do, or it gets rid of a lot of unnecessary overhead in terms of having additional people in trying to make those decisions. I'll tell you a simple example, another very simple example. We were working at a bottling unit of a very popular cola brand. um, this is when I was in school, when I was in university. I was working at a cola brand, and what they were basically doing at that particular point was, um, once the bottle, you know, this cola, when they get filled almost at a rate of 600 bottles a minute to 1,000 bottles a minute, right? So the machine runs at extreme pace, and when you think of these bottles actually go through a conveyor belt, and every time if the bottle was incorrectly filled or if the crown was incorrectly placed, there was a system that was in place um, which automatically pushes the bottle down into a gutter. Even before that, 5 years earlier, that this is the situation right now, but earlier to that, what happened was they used to make a person sit there and manually look at bottles that were incorrectly filled. So the guy used to sit there and he used to actually look at the person used to actually look if the bottle was properly filled or not. And if it wasn't filled, he would manually pick it up and push and set it aside. Humans are likely to make errors. We're not saying machines don't make errors, but what we're essentially saying is these are mundane tasks. These are tasks which have extreme cognitive load, and these can be handed off to machines, right? So with a little more error, it's okay to hand it off to machines. Because I can make use of that manpower elsewhere. Secondly, because I can reduce costs, right? Companies would want to reduce costs, right? So the question is, there's a lot for companies in doing this. There's a lot in place for companies to do something like this, to actually embrace data science, right? So we'll talk about more and more examples as we go along, but the crux of data science is, or the end goal of data science is to build these super cool intelligent systems that have the capability of making decisions all by themselves, right? Um, so to more formally describe data science and the field of data science is a process of finding hidden patterns from raw or unstructured data. Now let's try and understand this statement a little better. So when we say extracting patterns from hidden data, what we are saying here, firstly, the field of data science is not new to us, right? The field of data science has been there is almost a century old. It all started with statistics, right? Long, long ago, once upon a time, there lived a man called P.C. Malnobis, a very popular Indian statistician, mathematician, who believed that statistics could actually be made use in the field of in the industry. Um, Basically, applied mathematics or applied statistics could actually be made use in industry to actually benefit the industry in doing a lot of complex analysis. How do they make use of how does the industry want to make use of something like this? So think of it this way: if a milk supplement brand, let's take the example, right? If a milk supplement brand um, claimed that if you drink our let's take the example of, let's say, Horlicks, or Horlicks is a popular Indian milk supplement brand, milk powder, basically milk supplement powder that is generally given to kids. Horlicks claims that every time you drink Horlicks, or basically GlaxoSmithKline, that's the company that owns Horlicks. GSK claims that you drink Horlicks, you get sharper, taller, whatever, and you grow taller. That's what they claim. But they just cannot make these statements right out of the blue, right? They just cannot randomly say, if you drink Horlicks, you're going to get taller. Then I'm going to say that if you talk to me, you're going to get smarter, right? Companies, especially with that reputation, cannot make such claims just out of the blue, right? There has to be some analysis that goes into it. There has to be some kind of numbers that back this whole thing. So what do? So what they do is, and this is what is actually happening over a period of time. So let me quickly show you what they actually do. Let's do some quick whiteboarding on this. Right. So what these companies basically do is they basically identify a group of they basically identify a group of 5 to 10 people. Just give me a second. They basically identify a group of 20 people, 10 people here and another 10 people, or let's take this as 100 students, 100 kids, right? Two groups, group one and group two. This group is simply given milk, and this group is given, let's say, milk plus, let's say, Horlicks. And these two groups basically do exactly what each other do. I mean, if the group one does cycling, group two also does cycling. If group one eats certain kind of diet, group two also eats certain kind of diet. Everything is basically the same between group one and group two. It's just that the only difference between these two groups, to the extent possible, of course, it's not possible to control everything, but the only major difference between group one and group two is, of course, the fact that they drink Horlicks. Group two drinks Horlicks, group one doesn't drink Horlicks. They only have milk, plain milk. So now what you do is, now you go ahead and you conduct a simple experiment. So you monitor these groups for, let's say, a span of, let's say, 6 months. You monitor the groups for 6 months, and after a period of time, let's say you then again capture the growth rates of group A and group B, or group one and group two. You capture the growth rates. When I say growth rates, capture how many centimeters has each kid in group one and group two has grown. And after that, let's say you compute some kind of an average. Let's say the average growth of group one is, let's say, 2.5 centimeters, while group two people, is, let's say, 2.7 centimeters, right? Group one, the average height growth in height is 2.5 centimeters, and group two, who is having milk and Horlicks, the average height is, let's say, 2.7 centimeters. Now, just because you see 2.5 and 2.7, and because this number is larger, can we simply go ahead and claim that, group two has a higher growth rate than group one? Absolutely no. Just if tests were conducted like that, trust me, we would probably have been taking a lot of unnecessary drugs today, and a lot of false drugs would be available outside in the market, which probably are not really that effective. To really identify if your Horlicks is good or not, right? There has to be something more than just that. I'll tell you why, right? Though the growth rate in group B is actually higher than 2.5 centimeters, is actually more than group A, it could have so happened that there was some guy in group B who was probably a close relative of Usain Bolt, or let's say a close relative of the world's tallest person, and that guy just grew tall. I mean, that's a genetic thing. Or maybe there was two people in group B, or maybe there were two people in group A who actually did not do any kind of physical activity throughout the whole thing. The point that I'm trying to drive is that difference from 2.5 to 2.7 could be out of absolute randomness, right? So to perform more to perform a more complete analysis on if group B is actually better than group A or not, we perform we basically make use of a field called as statistics to identify if group A is better than group B, or group B is better than group A, essentially saying is Horlicks better than, let's say, plain milk or not. So that's where statistics comes into picture, right? Statistics has been like the most important pillar of how people have been analyzing data. Remember, we haven't done anything out of the world over here. We've just collected some data. Some we observed something happen. We've collected that data, and then we've simply analyzed that data, right? And that is exactly what statistics is all about. Statistics is a field where you aggregate numbers, you try to draw inferences out of numbers, right? You look at some numbers and you try to draw inferences out of it. You perform some analysis on a small sample, and then you try and identify if this is actually correct or not. Extrapolate this to larger problems, like, let's say there is a beer manufacturing company, right? A beer brewing company. You don't call it manufacturing, call it beer brewing company. And the beer brewing company believes wants to identify if um, a particular batch of beer is, if it's of the highest quality or not. Or take, for example, a pharmaceutical company which wants to identify if a particular vaccine, take the example of coronavirus, right? it's all over the place today, right? Especially in our side of the world. So what you do is you simply try and identify if that particular vaccine, if it is actually better than the existing vaccines or not. So you do some kind of trials and you collect data and you try and identify if the vaccine is actually helping out or not. All of that analysis is fueled and powered by a sim and a very important field of mathematics called as statistics. That's the core and the fundamental pillar of any kind of analysis that people have been doing. And remember, statistics has been there for a few hundred years now. It's more than a century old, if we were to say, right? So the fact is that the stepping stone of data science, which is statistics, which is basically the art of analyzing data, analyzing historical data, has been, or the seed has been sown almost a century ago, right? And people have been practicing that field over and over, right? What people have realized is, as time progressed, in the mid 1950s, 1960s, when computers started to come in, right? People started to realize there were computers and people started to build these abacuses and computer algorithms started to come in. Computers did not become a household thing only until, let's say, 1980s, so to say, but computers did exist in the mid 1950s and 1960s. A man by name Samuel Arthur, he came up with an interesting concept. He said, while statistics is a field where there was a lot of analysis that was being done by pen and paper, but why don't we actually make computers do it? Why don't we make computer algorithms which would automatically extract hidden patterns from data? Instead of actually us doing this analysis manually, why can we not write simple computer programs that can automatically extract patterns? So that is where the field of mathematics, that is statistics, and computer science started to amalgamate. They started to come together. And that field where computer science and statistics came together, right, was basically referred to as machine learning. A new field took birth, right? Machine learning it sounds cool. Basically, the concept is the term basically says you're building a machine that can automatically learn or that can automatically extract patterns, right? That is what machine learning was all about. Time progressed, machine learning evolved. In 1980s, as as people started to realize, as people started to collect more and more volume of data, problems also started to become more and more complex. 1980s, a man by the name Jeffrey Hinton uh, then realized that while machine learning is a computer algorithm that automatically tries to extract hidden patterns, this man, Jeffrey Hinton was one of the many scientists. He's not the only father, but of course he's one of the popular ones. He was intrigued by how human brain worked. This man was intrigued by how intelligent human brain was. Of course, there's a lot of analysis that was going into the neurological space, neurosciences. But this man was intrigued by computers and human brain. So he wanted to build systems. He wanted to build computer science algorithms that would ape how a human brain was. That basically was the stepping stone. So he wanted to build systems that would act like the human brains, or that could basically try to ape like human brains, right? So for example, when you see a particular object, imagine how your eye captures information and how your brain processes that information. When you look at a human being for the first time, your eye captures, there is a sensor, basically your eyes are sensors that capture this information, and there's a part of the brain that stores that information, and there's another part, the next time you see that particular person, the same person, probably he might be wearing a completely different dress, but you still remember that same person because there are certain elements of that particular person's face that your mind is capturing. And the point is, uh, and the point of course is that this particular man believed that we could build systems that could automatically um, that could act like human brains, and that system was called as basically neural networks, right? This is basically a sub part of machine learning. If I were to say, machine learning is like the larger is like the larger piece. They wanted to build computer algorithms that would act like neural networks. This is in 1980s. 1990s and 1920s, people became more and more intrigued by this idea of neural networks, and they started to build more and more complex algorithms, more and more interesting algorithms that could identify faces, that could identify text, that could do some really cool stuff with text, and that could, today modern day systems have the ability to write text by themselves, right? Or you pass a color photograph, to pass a black and white photograph to a particular algorithm, and it would basically do all the color corrections and add color to that particular photograph as well automatically. Now, the point is that this is basically the evolution of the field, and one of the latest inclusions in this is called as deep learning. When I say latest, I'm talking about 15 years old, right? Um, Deep learning is one of the latest inclusions in this particular field, and the cool thing is there are more and more complex algorithms coming in this field almost on a daily basis. There's so much that's happening, right? So the point is that data science is, now if I were to point a finger and say this is data science, all that you see on your screen is data science, right? There's so much that actually goes into data science, right? So there is statistics, there's machine learning, there's neural networks, and there is a completely different side of it where you have to learn computer programming. And if I were to kind of put this in a simple representation, this is what data science is all about, right? What you have here is, just a second, what you have here is the most important piece, which is statistics. The other side, which is the algorithms and machine learning. You have statistics and you have machine learning on one side. And along with these two together, you have one more very, very important aspect, which is, let's say, your data analysis, which is the ability to perform some quick data processing and do some kind of quick data manipulations. So you've got to understand how to work with this data as well. All of this put together is what data science is. So the point is that data science is not just about learning one side of the whole story. So if by now you would have understood that data science is not a tool, data science is not a programming language. There's a reason it's called science. It's a field of science. It's a field of science that basically performs, that is tied very, very closely to pattern extraction. And if you're someone who really likes pattern extraction, if you're somebody who really likes extracting very, very interesting patterns from for businesses, like for example, people who use 1 GB of data and let's say belong to a particular locality are most likely to churn out from a particular telecom company. Extracting these patterns and then building complex algorithms that can automatically make these decisions on the fly is what data science is all about, right? So the other cool thing why data science really shot to fame over the last 10 years is because less 10 15 years is because of the presence of data. Hardware became cheaper. Our company started to store large volumes of data. I still remember and I'm a millennial, but imagine if and I remember let's say my first computer actually having 256 MB RAM, and people would be laughing at me if somebody who's probably born before me, right? They would probably even remember systems that had let's say 256 KB of RAM and things like that, right? So they were dealing with KBs long ago. But then the point is that storage became cheaper, hardware became cheaper. People started to store more and more data, and machines became cheaper, which meant that we were now able to afford machines with larger amount of RAMs, which means that I can actually crunch all of that data and generate and process all of that data and extract patterns from it. Of course, you cannot do it with pen and paper. Of course, you cannot do it with Excel. You need more complex tools. That's exactly where the tools come into picture. And the tools are like, let's say, your Python, your R, and a lot of other tools come into picture. And those tools really help us in performing complex data analysis, right? So if somebody asks me what is data science is the field where of pattern extraction. How do you perform data science? Well, there are numerous ways of performing data science. One of the most popular ways of performing data science or performing data science analysis is via, let's say, tools like Python, via R, or there are a ton of other Spark, right? TensorFlow, and so on and so forth. So there are a ton of other tools that are available outside in the market today, which have grown in popularity over a period of time. And I'll talk about that also in a few minutes. But net, this is what data science is. Let's move on a little further, right? This is the point that I just mentioned about why do we need data science, right? The primary reason why we need data science is, of course, because almost since the year 1990, we've seen is there's been a sudden spike in the volume of data that is being generated. Year over year, we see that the data growth is simply exponential. A lot of internet-based companies are coming, a lot of e-commerce companies are coming in, a lot of small and medium businesses are completely switching digital. Everybody has a mobile phone, everybody uses social media, everybody uses WhatsApp, and and everybody now performs transactions with digital wallets. Nobody actually uses actual money anymore. Everybody uses credit cards and all of those transactions, which means that imagine just the volume of data that's getting generated throughout the globe. Every time I move from one place to another, data gets generated. How? Because I have a watch on my phone, on my wrist, which captures the number of steps that I move. Right? I move, this data getting generated. I sit and I work. There's a ton of data that, let's say, my Windows system is generating. So the point is, data is everywhere. Their data is getting generated everywhere, and every company wants to analyze that data and then identify some interesting patterns of how people are how actually they're using their product, which means that every company wants data science. And if every company wants data science, every company wants data scientists. And if every company wants data scientists, you got to take this course. Just kidding. But then the point is, it's a good time for you to actually move into this field, more so because we've never seen, and data science as a field is here to stay, right? It'll evolve over a period of time. um, it'll become more and more smarter, more and more complex problems will be solved, because the ones who are going to come in later are only going to be left with complex problems, because all the easy ones we've already solved them for them. Right? So the point is, the field will evolve over a period of time. You would suddenly realize that your 9th standard or your 10th standard kid is already learning data science probably in their school. It's already happening, right? Kids are learning data science and engineering already, and then it's a matter of time before they start learning data science in their school, in some form or the other. This would more or less become an essential skill, and this is not a hype that would die off after a few days, right? The other interesting thing is also about, take the example of credit card fraud. I'll tell you a classic example of how fraud detection systems really work, and not credit card fraud, but let's talk about a different kind of fraud. Let's talk about the fraud that happens in, let's say, an e-commerce industry. We can also talk about credit card fraud. That doesn't matter. Something more relevant is the e-commerce industry. So let's say you as a user, right? You are a user. You're using, let's say, your e-commerce platform, Amazon.com, Flipkart.com, whatever.com, some e-commerce platform.com, and you've performed a particular transaction on this. Right? When you perform a transaction, what happens is, this is basically you and your house. The moment a transaction is performed, of course, an order is placed at the background, right? There is an order that is placed at the background. But at times, if you've observed, what happens is Amazon doesn't directly approve your order. You don't get an order confirmation right away. But Amazon takes a few minutes before they confirm your order. But what happens during that time? There are multiple things that happens during that time. The first thing that happens is they go back and they check if the product is available or not. They identify which seller to pick up, and they identify all the logistics behind that. That's one side of the story. The other thing that also happens is they validate if the transaction that you've performed, if it is a valid transaction or not. They identify if the transaction that you've done is, if it's a valid or a fraudulent transaction or not. So what happens at the background? I'll tell you what happens. So the moment you perform this transaction, there is a bunch of information that is sent, like your name, location, time of transaction, the amount, the product, right, and so on and so forth. A ton of information is sent to if I were to say an intelligent system at the background, let's call it an a data science predictive model. We call it predictive models. Predictive models are simply nothing but um, these are a bunch of simple mathematical equations that are learned from historical data. So there is some kind of a model that is sitting at the background, right? So some information is sent to this, your name, address, location, whatever, all your information is sent to that particular, the amount of money that you've paid for that product and the mode that you made that payment from, and so on. It's sent to this, and this spits out if your transaction, if it is a fraudulent transaction or a genuine transaction. Now, the moment it predicts, so it gives some level of probability. It says that this product is this transaction is an 80% fraudulent transaction, and this transaction is it's only 20% genuine. So if it identifies that it is 80%, what happens after this is then it is likely that you could get a phone call from Amazon verifying if you have actually performed this particular transaction or not. So you are likely to get a phone call from Amazon, or let's say from your bank as well, verifying if that particular transaction that you've done. And there's a whole system, the whole set of a team that sits at the background, which makes these phone calls, right? There's support center people, customer service people, fraud detection, customer support division from Amazon, or let's say from Flipkart or any of these companies. They automatically pick up the phone call, and they dial you up and they verify if you've performed, if you've done the actual transaction or not, and they verify if the transaction is fraudulent or not. Then what happens after that is quite interesting. If they realize that it's a fraudulent transaction, it is a +1 for your model. Your model is is happy that you basically, because your model has predicted something and your model has actually learned something. If your model is predicted that this is incorrect, it predicted that it is fraud, but then in reality it is not fraud. You called the customer service guy called up the customer and he said that the transaction is a genuine transaction, then it's a -1 for the model. So figuratively speaking, what we do over here is we retrain, or we remake this particular data science model relearn from the new data, right? So what now happens is, now this fellow is fed this information back, and we ask him, or this data science model is retrained on the latest data, so that now it starts to recognize more and more interesting patterns from the latest data that has been sent to it. Okay, but the question is, how was it trained in the first place? How was it trained in the first place? The way it was trained in the first place is, what Amazon would have done is Amazon would have collected a large list of information, starting from the name, address, blah blah blah, transaction amount, so on and so forth. And they would have also identified if the transaction was a genuine or not. So they have a flag which says fraud, no fraud, fraud, no fraud, fraud, and no fraud. They pass this information into a predictive model. And when I say predictive model, these are the models that you typically hear names like decision trees, random forests, regressions, and so on and so forth. Those are the terminologies that basically come in here. So we pass this to that, and this particular model automatically, this model, what it then does is you pass this particular data into a model, and this gets trained on this data, and this fellow becomes now smarter. This fellow is now very, very smart, because now it has learned all of this data. So this fellow is now ready for performing predictions. So now what I can do is I can pass a new record to it, something that looks similar to this. I can pass it to it, and this fellow will identify if it is fraudulent or not fraudulent transaction. It'll make those predictions. The moment I'm happy about the performance of this fellow, I take this fellow and I put him into production. I take him and I put him into production. And then we continuously, and this fellow is like now in the war zone. Every time a transaction comes in, this fellow predicts if it is good or not, if the transaction is valid or not. Now, this system is now become an intelligent system. Earlier, how was Amazon doing it? There were people who were manually trying to identify if the transaction was genuine or not. Because there was manual verification that was happening at the background. Now what they've done is they've replaced that manual verification with a intelligent system. So when you place a transaction and when the order doesn't get confirmed automatically, what's happening at the background slowly is that it would take a few minutes. The Amazon machine or any e-commerce platform, what they do is they go back and check if your transaction is valid or not. Now this is valid even for, let's say, a credit card company. If you make a transaction on, let's say, your credit card, and let's say this credit card transaction suddenly comes from Vegas. I don't know how many of you all have actually realized this. If you make a sudden transaction with on against a company where you've suddenly traveled out of the country and then you've performed a transaction, the very next moment you get a phone call from from the company, basically asking if that particular transaction is valid or not. It's the same concept there as well. Think of it this way: every time a mail comes into your inbox, what your email does, your email server, your Gmail, or let's say your Outlook, what they do is they predict if your if this particular email, if the content in that particular email, if it points it towards a junk email, or if it is, let's say, if it is a genuine email. Based on that, it would drop it into one of these two places. So there is a lot of intelligence that goes into that as well. So based on how you where you use this kind of a concept, um, there are numerous applications of this particular system that we've just learned, and there are so many ways that you could that you could actually implement these in so many industries that you could actually implement this particular thing, right? Let's go back. That is basically what we mean by credit card fraud detection, credit card fraud, or any fraud detection. There's so many things that go into predicting fraud, right? I see some question from Kodishwaran. There are so many parameters that go into it. It could be the location from where you're performing the transaction, all the financial details of your mode of payment, from which bank it's getting routed, from which country it's getting routed, who is the issuing company or the issuing bank, and from which country is it based out of, and there's a ton of other, and what product have you purchased, what's the price of the product, and so on and so forth. There's a ton of information that goes into it, and it's not a manually crafted pattern, right? These patterns are learned over a period of time. Cool. So where can you implement data science? Data science basically can be implemented in a ton of places. These are just a few of the many that can possibly be that can possibly um, that where you can actually implement this. You name an industry and I'll give you 100 use cases of 100 use cases of, if not I, at least there are people where data science is currently being implemented. It's just that we don't actually have to see it, because systems are becoming intelligent by the day, which means the moment you don't realize something dumb happening, that means there's a lot of data science that's going on at the background. Swiggy, or your Zomato, or let's say your DoorDash, all your popular food delivery apps that you have in here in your own respective countries. There's so much intelligence that goes into it. What dish do you want to what dish do you want to eat, and what kind of um, what restaurant do you want to order this from, and so on and so forth. So much intelligence that goes into it, right? Predicting the ETA of your delivery, 20 minutes, 30 minutes, identifying how long would the delivery person actually take to deliver the product to your house. There's so much that goes into that as well, right? Now the thing is, there are these popular names. I actually don't want to confuse you all with all these names. These are those popular names and popular terminologies that you would see outside. When you see these names, now this is not to this is not to a either show off or b to tell you all these complex jargon and frighten people. This is basically to simply tell you that when somebody talks about data science, these are common terminologies that people often use, the common jargons that they use. These are not really that complex, to be honest, right? So these are all those cool techniques where which is basically helping this algorithm to learn, right? All those are those cool techniques that is helping that algorithm to learn if a transaction is fraudulent or not, if the car should take a left or a right, or predicting if a customer would quit or not, would churn out or not. Imagine your company is doing some kind of analysis on you guys, on predicting if you would quit your current job or not. It's scary, right? But then it actually happens. A lot of companies spend a lot of time in predicting if you guys actually um, if you guys continue to work, if you will continue to work, or basically predicting employee attrition. A lot of companies do this analysis. What goes into it? Think about it. Think of what kind of digital trails you're leaving to your own company. Uh, so your browsing patterns, your leave patterns, your work style, your performance, all of that is a nice indication of your interest towards quitting the company. How often do you visit the careers portal in your own company? How often do you visit LinkedIn? I don't know. I'm just saying. Um, I, I mean, they could do it if they want to, but then we don't really know how many companies actually do it. But then, yeah, these are interesting scenarios to predict if you're going to quit the company or not, right? So all these are those algorithms that are going to help us build intelligence in extract patterns from your data and then build these cool models, so to say, right? uh, I'm going to talk about this a little, and I'm going to talk about this a little about what data science processes really are. um, the first and foremost is about how do you solve a data science problem. Now remember, data science is all about uh, if you want to extract pattern from your data, you've got to pass the right data into it. So Zafar has come back with a question saying, why are algorithmic traders not rich? Well, the algorithmic traders are not rich because data science is not magic. It's not sorcery that is automatically going to extract patterns for you. When I say extract patterns, there's a lot of work that goes into training these algorithms, right? There's a lot of work that goes into passing the right kind of data, extracting the right kind of data. If I ask you what impact, let's say, the stock price of Amazon, right? There are a million things that impact the stock price of Amazon, right? So then how do you, if you can pass all of that information to the algorithm will do well. Now tell me one such scenario where all such information is readily available for you. Not just for you, even the algorithmic traders are not going to get all of that information. If you have that information, then you're rich. So that's the reason data is like gold mine today, is more costlier than gold mine today. So you have all of that data with you, then you can mine, or then you can build these complex algorithms. If you don't have that data, there's nothing that you can do about it. So data is the next most important natural resource. If I have the data, I can do wonders with it, right? So that's the reason why not all algorithmic traders are rich. A lot of algorithmic traders are rich, by the way. Not all of them are rich, at least. Okay. Um, a typical data science solution goes through a typical data science solution goes through a certain set of phases, steps, if I were to say. The first one, let's say, for example, take that example of fraud detection algorithm that we just spoke about a while earlier. Uh, the most important piece of data science is to understand what business problem to solve, right? Technology is readily available for us. There is technology that is there. You could make use of tools to solve a problem, but then you need to know what you want to solve, right? So it's like having a calculator with you. A calculator is only as efficient as the user, right? So if you don't know what to punch into the calculator, and if you just learn how to add two numbers in the calculator, you'll only be adding two numbers in the calculator. Similarly, data science is a long list of techniques that are available with you, but you need to know where to apply these, Right? To know where you want to apply these, you need to understand what business problems are available outside. So if you're working in, let's say, a telecom industry, or if you're working in an insurance industry, or let's say you're working for a stock brokerage company, you need to know what is the most important business problem that you'd want to solve. So understanding the business problem is super critical. When I say a business problem, take for example, my most important issue today as a telecom company is that a lot of customers are quitting my service and joining someone else. So can I build an intelligent system that can automatically predict who are likely to quit and then give them a relevant offer so that they stay back? So now what you've done is you've basically converted a business problem into a data science problem, right? So converting such business problems into data science problems is super critical, and that's what the first step is going to be all about. Once you move this from, once you identify a particular problem and then you try and uh, you decide to solve that particular problem, then you move to the most important phase, which is the data gathering phase. And the point that I just mentioned to Zafar a while ago is the data gathering phase, where you try to gather as much data as you can about that particular business problem. So think of, in a telecom company, what are those factors that really cause a particular person to quit, right? bill Bill shock is what we call it. Bill is a primary reason why people quit. People quit also because of bad service, call drops, right, is one of the biggest issues. Bad internet issues, right? Network availability is a big issue. uh, Value added services, you don't have enough value added services. All of these are major reasons why people typically quit. So what you're essentially going to do is you're going to move from the field of you're essentially going to capture all of those features, and then pass that into, and then do some kind of quick data analysis and data processing. So you capture all of that data, but all of that data is not going to be in the best format for you. So what you do is you identify if the data is of good quality or not, and then what you do is you go ahead and you join different data sets from different data sources. I get data from, let's say, the billing system. I get data from the network system. In a telecom company, each system is separate. So I collect all of this data, I bring all of that data together. Once I get that data together, I do some basic analysis about if how good my data is. I do some quick visualizations just to understand my data a little better, right? Picture speaks 1,000 words, right? You don't really have to spend a lot of time in actually analyzing the data. Visualize it, and then you'll start to see interesting patterns come out of charts. You create those interesting charts and visuals. Becomes very easy for you to digest your data. Then what you finally do is you then prepare your data, and then you go ahead and build your model. Building the model, all of this has, building the model is basically using the techniques that we saw in the previous slide. A few, I mean, they're more than these techniques, to be honest. These are just an example, commonly used techniques, but they're more than these techniques. If I were to list them out, it would probably take me the next half an hour to list all of them out. There's so many techniques are available out there, but basically the point is, we use those techniques to solve these problems, right? Creating and testing a model. Once you're comfortable, the next step, of course, is to go ahead and deploy it. That's basically the life cycle of your data science problem. Now, I've oversimplified the whole process, but at a 10,000 feet level, if I were to explain you what is data science and how data science problems are typically solved, this is a nice representation of how your data science problems are generally solved. Okay, there are more layers to this, and there's a lot of layers on how um, on what kind of people are involved in this whole exercise. One of the things that I'd like to talk about in this particular slide is that, as a data, see, if you imagine, until here, until your last step, 6 out of the 7 steps have got to do simply with data, data cleansing, data extraction, data analysis, and this and that, and this and that. Everything has got to do with data. So remember, garbage in, garbage out. All right. So if your data is not of a great quality, then your system is not going to learn any patterns out of it. If you don't have any patterns in the data, then you cannot extract those patterns. So don't blame the algorithm for it, blame the data for it, right? So you've got to make sure that your data is of the is of a great quality. If the quality of the data is good, then automatically your patterns are going to get extracted very well. Okay. So because a lot of our work has got to do so much to do with data and so much to do with data extraction and so on, what we have seen is that there are a certain set of roles that most frequently operate with data scientists, and I'll tell you what they are. Right. So there is a data scientist, of course. The prime responsibility and the prime expertise of this data scientist is to apply these complex algorithms and it perform pattern extraction and so on and so forth, do visualizations and do some pattern extraction and so on. But what we've also seen is that certain aspects, um, you cannot expect the data scientist to do data gathering and also to do deployments and everything, right? So there are people around the data scientists who help data scientists, right? There are other roles around data scientists who help data scientists quite a bit. Typical terminologies are, you have a data analyst or a data engineer. Let's call him a data engineer. A data engineer is someone who is responsible for doing the data gathering, right? So data engineer, what they do is they build data pipelines, they collect data, and then they put it in a particular location for us to use it from there on. That's what a data engineer is all about. Then you have, let's say, we then you basically have somebody from, let's say, your deployment teams. We call them, you know, you can also call them as uh, let's simply for the current sake, let's call them as deployment specialists or deployment teams. um, they are responsible for deploying the models that you've built. So you've built a model and then they often take the model from you and then they go ahead and they deploy it in the production systems. They are the ones responsible for scaling out your problems. We call them ML engineers, um, big data engineers, and so on and so forth, but essentially these are the ones who are responsible for your deployments. And then on the other side, you also have some business specialists, business experts who specialize in the business side, business stakeholders. They are the ones who understand the business. They are the ones who evaluate if the models that you've actually built is of real business value or not. But in a lot of ways, a data scientist is also expected to bits and pieces of each of these. It depends on the size of your organization, size of the company that you're working in. Certain companies, you have these teams well demarcated. In certain companies, you might not. As a data scientist, you're expected to do all of it by yourself. So it depends on the um, it depends on how big your organization is. It depends on how well structured the data science teams are there in your organization. But remember, your core skill as a data scientist and your core skill out of this course that you're going to learn is going to be data science, which means it's the art of pattern extraction. Don't expect yourself to learn data deployment at the end of this course. That's not what we are headed towards. Don't expect yourself to build data platforms at the end of the course. That's not where we are headed. What we are headed in this particular course is to equip you all with all the necessary skills as a data scientist. Right? What do you mean by data scientist? Somebody who can explore data and understand and build these intelligent systems, understand the data, visualize data. Somebody asked me, why do you need to visualize data and why do you need to clean data? Imagine, a lot of companies, what happens is when you fill your data set, when you fill an application form, how many of us have filled the application form with utmost with utmost commitment? Half of us don't even care about the fields that are there in certain application forms, and we choose not to write them. So there's a lot of data cleansing that needs to happen. So when you're manually typing in forms, manually entered data requires a lot of data cleansing, right? Because I might write, let's say, I might be very bad at my spellings and I might write the term Philadelphia incorrectly because I did not learn the spelling of Philadelphia correctly. But you might require some kind of data cleansing to clean these incorrectly written data out. You might also have to write, so somebody might write their pin code as 00000, just so that people don't get to know what their pin codes are. So there is some kind of data cleansing required to get rid of such data set, such records. Hence, data cleansing becomes really important. And why do we need data visualization? The reason why we require data visualization is because you might be doing a ton of analysis, something that only you understand. But then how are you going to convey the story to, let's say, a how are you going to convey this story to somebody who does not understand data science? The best way to do that is by putting in charts together. You perform some kind of simple visualization, and that visualizations are going to help us in conveying the data story to somebody who's not from the data world, so to say. That's where visualizations become super critical. They are a very, very strong form of communication to a community that does not understand data at all, right? Hope that makes sense as well. Um, So the point is that there is a ton of roles that are available outside today, but remember what we are targeting is a data scientist. I mean, there are different names that people are called at, of course. You also have a term called as big data, right? All of this is great, but what is big data then? So big data is where things become very interesting. Big data is basically that particular field, which is got to do with the data engineering side of the world. Right? Big data is a field got to do with the data engineering side of the world. I mean, partially with data engineering and partially with data science. There's an overlap between the data science and data engineering world. So if, for example, if you were to deal with large volumes of data, right? Take, for example, the amount of data that an aircraft engine generates. An aircraft engine has got a few hundred sensors on it, and every second ton of information is generated from one single engine, and there are so many engines, there's so many flights that are in flight, and across the year there's some millions of terabytes of data is generated in a given year by, let's say, a simple aircraft carrier. Your cars generate so much data, right? When such large volumes of data come in, the first question is, where do I store it? Like, forget about analyzing it. Firstly, where do I store it? Right? So then you require complex data platforms to be built, interesting data platforms to be built, so that you can store that data, and not only store the data, also retrieve that data. So big data analyst, or when you say big data and big data analyst and Hadoop and things like these, are basically technologies that help us in building these complex data platforms. Let the data flow in. But then what is big data analytics? Why does the term analytics come in there? The reason why analytics and big data and data science are often very well spoken together is because at the end, the largest consumer of this data is a data scientist. So what does a data scientist do? A data scientist then takes that large volumes of data and then builds complex algorithms. What that means is that we should, as a data scientist, I should also be well equipped to not only work with small volumes of data, but also work with large volumes of data, right? That's one of the reasons why a data scientist is also expected to have some knowledge about big data, right? So remember, a big data analyst is somebody who is or big data engineer is somebody whose primary responsibility is to move large volumes of data from one place to another place, store them, do ETL, do some transformations on data, do some loading of that data, and that's where they are. That's their space. Our space is to make use of that data and build complex algorithms, and there's an overlap between these two. That's basically where big data and data science sort of have a slight overlap. But remember, um, it's not our responsibility. And a lot of companies have this very well demarcated. Even the small companies have a data engineer and a data scientist well demarcated. Um, Generally, there's a decent demarcation even in small companies. But again, it depends on the role that you're picking up and things like that. The tools that we will generally be learning that you as a data scientist, I'm not talking about it from a simply the course standpoint. I'm talking about in general data science as a field. What has happened is Python has more or less become the ruler of the industry today, right? Python is the most popular data science most popular tool preferred by data scientists. um, Second comes R. There has been a very tough competition between Python and R for a very long time, but slowly what has happened is Python has taken over. Python has become more and more popular. The reason, of course, there being the fact that Python has more capability. It's much easier to build Python models for production. R is great for experimentation, but Python is really great to build production grade systems. So that's the reason people have moved away from R towards Python, and that's the reason that's one of the cool things about how Python has become really very popular. Um, so Python and R are, of course, the two most popular tools for doing data science. Um, Python is of course meant to do a ton of other things as well. You can build websites using Python, you can build games using Python, you can build web apps using Python. There's so many things that you can do using Python. You can do data engineering using Python. There's so much that you can do. The only point is that Python as a tool, one of the key things that you could also do with Python is data science, right? So we're going to use Python for data science, and whenever you attend a data science session, the kind of Python that you're going to learn is, of course, you're going to learn the basics of Python, but of course, you will learn Python from a data science lens. So you're going to learn all those libraries and all those tools and packages that will help us in performing data science analysis, right? So that's basically tool number one. In parallel, while these are tools that are really cool for performing analysis, what has also happened is to be a really useful data scientist, the other thing that you are also expected to learn is some SQL, right? Why do you need to learn SQL? Remember, I mentioned to you that our responsibility is not just about building models. Our responsibility is also to take that data and build models. Take a data that is available somewhere and then build models. Nobody's going to feed things into our mouth. So, which means that a data engineer is going to do his part of moving the data and then putting it in a particular location. But from there, moving that data from the databases and doing some quick analysis on the database side and then moving it into your own Python environment means that you will need to learn some SQL as well, some basics of SQL as well. While these are great, the other, if you move from, let's say, basic and intermediate courses to advanced courses, what you will also learn is Python also has got more complex variants in it called as, let's say, PyTorch. For example, if you're learning, moving from traditional machine learning to, let's say, deep learning courses, so then you will have to learn other packages of Python. When I say packages, other modules of Python, which are called as PyTorch or, let's say, TensorFlow or Keras. These are the ones that are going to help us in performing big data. So these are the ones that are going to help us perform deep learning. So this will help us in deep learning and let's say neural networks. So this is basically regular machine learning, but if you want to move from regular machine learning to advanced concepts like deep learning, this is basically where the play is going to be. You'll have to learn these tools like PyTorch and Keras and TensorFlow and things like that. That's where, don't think of these as different tools. They're just different modules of Python. That's about it. It's still Python as a programming language only. Okay. On the data science, on the data engineering side, what you will need to learn, while SQL is good enough for regular machine learning and simple data, when you're working with complex data, large volumes of data, that's where you might have to learn a tool called a Spark. Why? Because the moment the volumes of data become larger, you cannot fit a 1 terabyte of data in your machine, right? You'll not be able to open it. Forget about doing analysis. You will not be able to even be able to view that data. So to actually perform such large volumes of to perform analysis on such large volumes of data, that's where Spark becomes very useful, right? So that's where we'll have to learn Spark as well. And that is basically what you see on your screen is the landscape that is currently available today. Python, R, SQL, and of course you have Spark and other tools as well that are available outside today. Okay. So that's the landscape. In most of the courses that you're going to see, even in the Intellipaat course, and let's say most of the courses that you will typically see, this is, if you, I mean, being a good Samaritan, you got to make sure that the tools that you're seeing outside are covered. Wherever you pick up, whatever course you pick up, got to make sure that the tools that you see outside here on your screen are covered. At least one of these two, this, and this, basically is what you should ideally be looking at based on again the complexity of the course. If it's a small course, just a short course, then Python, SQL are good enough. But you're taking a longer course, then expect yourself to learn all the other tools as well. Deep learning is the next big thing of big data. Deep learning is the next big thing in data science. Big data and Spark are basically for, are on the data engineering side. Think of it this way. Spark, big data are on one side of the spectrum. Deep learning is basically the next big thing in the data science industry. It's not the next big thing, it's already the big thing. I hope that answers your question. What is a growth path of a data scientist? Okay, cool, good question. I think that's a valid question, and I'm going to spend a minute on that. So Saurabh, for a typical data scientist, right? what happens is a data scientist can actually join in as an apprentice, a junior data scientist, and can become a senior data scientist, can actually become a lead data scientist, a data science manager, and then you can have a VP data science and CEO data and analytics and so on. And sorry, a CIO data or a VP data and analytics and so on and so forth. So you have roles starting from as low as, let's say, an apprentice entry level data scientist, all the way till the end, right? All the way till a CXO level, so to say. So there is, in a lot of large organizations, these roles are very well defined, and there's a nice career path, so to say. But in general, if you want to be a data scientist, expect yourself to be a hands-on data scientist, at least for the first few years. Don't expect yourself to straight away enter as a manager, or let's say as a lead straight away. Expect yourself to do some kind of hands-on initially as an individual contributor, and then you can move into other larger roles. There are two kinds of data. The first one is structured and the unstructured. I'm going to repeat this point for you all once again. Structured and unstructured data. I think the structured data that we're talking about is data that can fit in a table, right? In an Excel sheet like a format, right? You have rows and you have columns, so you can basically enter data in a row and column format, right? So think of it that way. Um, so you have customer ID, and then you have, let's say, information about all that particular customer, and all of this information is nicely stored in, let's say, a tabular format. Unstructured data is data that does not fit in a tabular format. Take the example of an image, photograph, right? When you want to do some kind of analysis on a photograph, or you want to do some kind of data analysis on, let's say, videos and audio and so on, that does not fit in a Excel sheet, or that does not fit in a simple that you cannot store that information in a tabular format. Hence, such data is referred to as unstructured data, because there's no structure to that data, right? That is what we mean by structured and unstructured data. As data scientists, we work both on structured and as well as unstructured data. Okay, that is what we mean by structured and unstructured data. Good question, awesome question. I know many people in the industry who can analyze Excel sheets and give solutions to companies. The point is, I wish all problems were that simple. If people are simply analyzing Excel sheets, then trust me, those companies are are not large enough, right? So modern day data that we're talking about can no way fit in an Excel sheet. When I say that, what I mean is I'm not simply talking about the volume. I'm talking about the complexity around the data. Right? There's so many data sources. There's so many data sets. All these data sources and data sets have to be combined together and then analyzed, and then build these intelligent systems. So what your friends are probably doing in those companies are simple data analysis. We used to call them as reporting, right? Reporting is basically building some simple metrics and simple data analysis. That's about it. But then we're doing something beyond that. We're definitely doing something way beyond that, because we're actually building systems that can extract that can basically extract intelligence from such large data sources put together. Yeah. Okay, is big data related to data science? I had answered this question already during the session. The answer is yes, they are related. Big data is basically a field that is related to data engineering primarily. Data science is a slightly different field. Data engineering is a field which is responsible for moving data from one place to another place, building ETL pipelines. When I say ETL, extract, transform, and load, that means extracting data from systems and transforming that data, right? And then storing that data in databases and so on. That's what data engineering is. When the volume of data becomes very large, we call that as big data. So when we say big data, when we say big data analysis, big data big data engineers, basically they are the ones who are responsible for storing these large volumes of data. You have data engineers and you have big data engineers. But on the other hand, you have data scientists who are responsible for using these large volumes of data and then extracting patterns out of it. Right? We are the ones who are responsible for insight generation, building these intelligent systems. Right? So are is data science does data science is big data a subset of data science? The answer is no. There is an intersection between these two. There is an overlap between these two. Data scientists work on large volumes of data. Data scientists work on big data set, so to say. Yeah, that's basically the relationship between these two. Yeah, so I hope that answers your question as well. Cool, guys. Thank you so much. This was useful for you guys, and hope to see you all in the class someday. Thank you so much, guys. I'm going to hand it off. I'm on top of the hour. I hope this was valuable and useful for you guys. And Rahul, off to you.
Thank you so much, Srinath. Thanks a lot. Hello, everyone. This is Rahul Sharma this side. I'm one of the senior course advisors here at Intellipaat. So I hope today's session was fruitful to you. So herein, I would like to share my screen and tell you more about the job trends and the salary that you might expect in this particular domain. I hope my screen is visible to you now. Can you see my screen? All right. So talking about Intellipaat first, I believe many of you already know we are in this industry since 2011, and it's been around 9 years. We have been providing training to not only individuals but also to corporates. And currently, we are having a learner base of around 6 lakhs learners on our platform, and we are serving to more than 53 countries around the world. So as I mentioned, we are providing trainings not only to individuals but also to corporates. We have a good amount of insight that okay, what how exactly this particular domain is and what is the current demand in the market. You are already very much aware, and I believe many of you are interested because of this, because the average salary in this domain is very, very high if I compare it with other domains in the IT sector. So if you check the average salary for a data scientist currently in India is around 8 lakhs per annum. Also along with that, definitely if you check the bonuses or the commissions and everything, if you add, that is again added separately. So this is one of the key advantage. The average salary, if you compare it with any of the domains which is there in the market, the average salary is very, very high. For US, if you check, the average data scientist salary in the US is around 95,000 US dollars. So again, this is a very huge motivation, you can say, if you're looking forward to go towards this domain. When I talk about data analyst, the average salary it ranges from 4.5 lakh to around 5 lakh. You can say it ranges from 4 lakh to 5 lakh. For US, the average salary for data analyst is around 64,000 US dollars. And when I talk about data engineers, again, it is around 8.6. The average is around 8.6 LPA in India and 92,000 US dollars in the US. So why to learn data science and why to learn this particular domain with Intellipaat, if you have these questions. Guys, also one more thing, in case if you are having any questions for me, since I'm a course advisor here, I understand what basically the idea of putting course advisors in front of our learners is to make sure that we understand what is your requirement on what all tools and what all platforms you have worked on earlier. What is your objective? And accordingly, we can help you out to choose the right set of courses or choose the right set of path which can help you to reach to your objective quickly. So in order to make sure that all of our learners are getting personalized attention, so the first touch base you can say by Intellipaat side is us, the course advisors who are here. So in case if you have any question, if you want to know more about any program, or if you want to know what should you be choosing which can help you out in your career, then you can reach out to us. I'll also do one thing. I'll just give my phone number here so that you can reach out to me as well if you have any questions. Also, if you are having any question, if you want to see, if you want to, if you want me to answer any of your questions, feel free to write down your questions in the questions box. I'll be happy to answer that as well. Meanwhile, I'm just dropping my phone number as well in the email in the chat box, as well as I'll drop my email address here. So yeah, coming back to the topic, why should we learn data science with Intellipaat? So we are currently offering two job related courses. So the major and the most foremost, the most important thing here is that we have tied up with not only major IT companies, but also we have tied up with top of the institutions of the country. So the whole idea to do this is to make sure that we are having the academic rigor in all the trainings that we provide. Along with that, we also need to make sure that we are providing practical exposure also to all our learners. So in order to do that, we have tied up with IBM, and also we have tied up with ENICT Academy of IIT Guwahati, and for providing two courses. One course that you see on my left side is Data Science Architect Master's Program, which is in collaboration with IBM, and the other one is Certification in Big Data Analytics, so which is in collaboration with ENICT IIT Guwahati. So these two courses are, it has been designed keeping the current market demand, keeping the current market scenario, and how you can fetch a salary which is way greater than the average salary in these particular domains. So yes, so if I talk about the common features that we generally provide in these two courses, is that 24/7 support facility. See, most of almost all the training that we are providing, it is live classes that we provide, live online sessions that we provide, which happens on Saturdays and Sundays. The live sessions, you can speak to our trainer, you can ask your questions, you can clear all your doubts. These would be conducted every Saturday and Sunday for three hours. But along with that, people also, they go ahead, they need to do their own self study also. So for such scenarios, we help you out with e-learning video material that we provide. And whenever you are stuck anywhere, if you are having a doubt, then we are having our 24/7 support facility. So you can come back to us, you can drop a mail, you can give us a call, and we are there to help you out and make sure that your self-study which is going on, it is not being harmed. So as I mentioned, we are having our presence in more than 53 countries around the world. So we are providing around the clock support service. So whenever you are having any issue, feel free to reach out to us and we'll be helping you out. Plus lifetime free upgradation we provide in all the courses. So the lifetime upgradation is what, in case if there is any change in the technology, if there is any upgradation in a particular technology, you don't need to go ahead and invest your money again to take or to learn that change or to learn that upgradation. We provide lifetime free upgraded content. So whenever, if you see that okay, there are certain changes in this particular tool, then you can come back to us and you can learn it all over again. So this is one of the best thing that we make sure that our learners are getting. Along with that, job assistance we provide. We help you with mock interviews. We help you out also with one-on-one doubt sessions in all the trainings that we are providing. Along with that, these two trainings, the one which is with IBM and one which is with IIT Guwahati, if you ask what is the difference between these two, so here is the difference. In both the trainings, you would be getting 24/7 support. In both the trainings, you would be having free upgradation for your lifetime. You would be having flexible schedule. You will be having job assistance, mock interviews, and one-on-one doubt resolution that we provide. Another thing which is missing in the IBM course, but is available with the IIT Guwahati, is dedicated learning manager. A learning manager would be assigned to you who would be taking care of your entire learning journey. He'll make sure that okay, whatever assignments that you are submitting, how exactly is your growth, how exactly you are learning things, what are the areas where you are lagging behind, what are the areas wherein you need further more attention, is where we come, and this dedicated learning manager comes and he helps you out. So this is one added advantage that you get in the IT Guwahati course. Along with that, yes, having the certification from ENICT IIT Guwahati is a major advantage. If you just put this keyword on your LinkedIn profile for IIT Guwahati, trust me, your profile, it starts ranking higher. The chances of getting a job, it increases. Along with that, whatever you are learning from a faculty. So herein you get that benefit. Academic rigor is there. The course content has been designed by the faculty of IIT Guwahati. So that is one added advantage again. Plus, you also get the alumni status of ENICT Guwahati. So that is what is going to help you for networking. You understand this is the era of networking. The more strong your network is, it's very easy for you to go ahead and land up on a good job. Along with that, training by IIT professors, yes, that is there in the IIT course, but not in the IBM course. Along with that, weekly support sessions for solving assignments. So support sessions will happen wherein, again, like the classes that we are arranging in the same way, support sessions will also be arranging for this particular course. Okay, so coming towards the pricing, what is the difference of the pricing? The pricing for the data science applied master's program, it will cost you around 40,000 rupees plus taxes, 44,000 rupees plus taxes. And for the IT program, it is around 1.1 lakh plus taxes. So this is the difference between that. Along with this, if you are interested, if you are looking forward to enroll, for all the people who are joining our sessions, we are providing them a discount coupon that you can go ahead and apply on our website and avail the discount of up to 30% on our courses. The discount coupon, you can make a note of it. It is YouTube 30, that you can make a note of, and that you can apply on our website to avail discount of up to 30% on our courses. Along with that, see, the major thing is that first of all, you need to go ahead and speak to one of our course advisors who will help you to choose the right set of courses. They'll make sure that whatever course that you're looking forward to learn with us is somewhere or the other is overlapping with what all experience you had and what is your background and what is your objective. So that is very crucial thing in all the courses. Okay, I have got a question. when is the demo lecture of Big Data Hadoop program? Abhishek, I believe you can check your mails. We would be updating all our learners over the mail for our upcoming demo lectures. So you can check there. In the chat box, I have mentioned my phone number. You can reach out to my team on this number and you can clear all your doubts. Along with this, I am also writing down my email address. You can share your resume. I'll go through your resume. I'll understand your profile and I can help you out to choose the best set of course. Also, if you are looking for a better discount, if I understand your profile, if your profile is really, really good, then definitely we would also like to have such learners with us, who can help Intellipaat as well to grow. So in such scenarios, if your profile is really strong and if you're looking forward to the upcoming batches, I can provide you a way better discount, which currently I just short of 30%. I can give you a way better discount on the course. So for that, if you want to do that, if you want to first understand, and then look for a course and looking for a better discount, please reach out to me on this email address. And I have given my phone number as well. You can give a call on this number as well. Guys, some of you are again asking about the phone number. Let me know. Have you received my phone number? You can check the chat box. Did you get the phone number? Please write yes if you have got the phone number. Please write yes on the comment box if you have got the phone number. Write no if you haven't received the phone number. I'll give it to you again. Kevin, did you get the number? And this is India number for the learners who have joined outside India. Please put +91 and then dial that number. Also, this number is available on WhatsApp. If you want to have a conversation over WhatsApp, that also could be done. Okay, Rohit has a question. What is the placement percentage of Intellipaat? See, we are not, a job providing company. We are a training company. And in the IIT Guwahati program, this is a very important thing. In the IIT Guwahati program, we provide you minimum 3 exclusive job interviews, which is guaranteed. After that, it is up to you to convert. So we make sure that we are keeping all our learners ready with the mock interviews and resume preparation and whatnot. But at the end, it is up to you how you perform in the interview. So in case if you're going for the IT Guwahati program, in that you would be getting minimum 3 job interviews guaranteed. After that, it is all up to you. Okay, Kruti has a question. Is it considered as a master's degree? Because in most job profiles, they ask for prefer as a master's degree holder for certain job roles. So Kruti, this is basically, you can say, since the eligibility for these courses is basically, you need to have a undergraduate certificate. You must be a graduate, then only you can go for these courses. So yes, you can say it is a kind of a postgraduate program which is there. I hope this session today was fruitful to you and you got to learn a lot in this session. For any doubts, we are there to help you out, and reach out to me. You can be. I believe all of you have noted down my phone number. Also, in my screen, you can see the phone number of our sales team. You can reach out to us. We will be helping you out. Thank you so much, guys. Thank you so much for joining in today. Thanks a lot.